Greetings, viewer. Don't forget to visit my website for links to support the production of these works if you value what I'm doing. I appreciate any help you can offer. Thank you for having a look and a listen. Yours, John Loth. Recorded, edited, and produced by John Loth. The Evolution of Civilization by Carroll Quigley. Recorded, edited, and produced by John Loth. Chapter 4. Historical Analysis. We have already mentioned our belief that civilization is an object that can be studied in a scientific way, just as a quartz crystal can be studied. In such a study, we must, like the student of crystals, examine in a comparative way a large number of examples, even, ideally, all the examples available. But it is obvious that a civilization is a much more complicated object than a crystal. Let us be explicit about that word, complicated. A civilization is complicated, in the first place, because it is dynamic. That is, it is constantly changing in the passage of time until it has perished. Furthermore, a civilization is part of the social sciences. That is, it contains subjective elements, and these are usually the more important elements in the culture. Accordingly, in a civilization, unlike a crystal, what people think or feel can influence what exists, changing the object completely in the process. In the third place, many aspects of a civilization are continua, existing in such subtle gradations and in such varied degrees of abstractness that the divisions we make in it, in the course of our analysis, and the words we use as symbols to refer to our analytical divisions reflect only very roughly the situation that exists in the reality itself. All three of these difficulties are important, but the third, which is frequently ignored in discussions of these matters, requires a little further examination. For that reason, at least. Much, if not all, of the physical world consists of continua. To say this is equivalent to saying that much of the physical world is irrational. It exists and it operates, but it does these things in ways that cannot be grasped by our conscious rational mental processes. This can be seen most easily if we consider, first, a few examples of continua in the physical world. How many colors are there in a rainbow? Some answer 3: red, yellow, blue. Others answer 6: red, orange, yellow, green, blue, violet. When I was a child in school, for some unknown reason, we were told that there were 7 colors. The teacher inserting indigo between blue and violet. The proper answer, of course, is that the number of colors in the rainbow is infinite. This in itself is something we cannot grasp in any rational way. But let us consider what it means. In the first place, it means that there is, in the rainbow, no real line of division between any two colors. If we wish to draw a line, we may do so, but we must recognize that such a line is imaginary. It may exist in our minds, but it does not exist in the rainbow itself. Moreover, any line that we draw is arbitrary, in the sense that it could have been drawn with just as much justification somewhere else, perhaps only a hair-breadth away. If we draw a line between red and orange, and another between orange and yellow, we may call the gamut between those two lines orange, but, as a matter of fact, the color is quite different on either edge of that gamut. We may decide that orange is a narrower range than the gamut between our two lines, and accordingly slice off the margins of the orange gamut, calling the severed margin on one side yellow-orange, and the severed margin on the other side red-orange. But once again, the color is not the same across any of these 3 ranges. In fact, it is impossible to cut off any gamut in a rainbow, no matter how narrow we make it, in which the color is the same across the width of the gamut. We can move no distance, however infinitesimally small it may be, across the rainbow without a change in color. This means that the number of colors in the rainbow is infinite, but it also means that the number of colors in any portion of the rainbow is infinite. That is, there are as many shades of orange as there are colors in the whole rainbow, since both are infinite. Now, this is a truth that we cannot understand rationally. It seems contrary to logic and reason that we could add all the existing shades of red and yellow to all the existing varieties of orange without increasing the number of color varieties we have. The reason is not so much that infinity added to infinity gives infinity, as that there are no different varieties of colors at all, because there are, in fact, no dividing lines in the rainbow itself. When we use the plural terms colors and shades in references to a rainbow, we are implying that there are different colors, and accordingly that there are divisions in the rainbow somehow separating one shade from another, and thus entitling us to speak of these in the plural. Since there are no lines of separation, we would be more accurate if we spoke of the rainbow in the singular as a continuum of color. But, of course, we could not do this consistently, because it would make it impossible to think about or to talk about the colors of any objects. Since the continuum changes across its range, it is distinctly different in color from one portion to another. Just as dresses, flowers, or neckties are different in color from one another. If we are going to talk about these very real differences, we must have different words for the different colors involved. Thus, we must give different color terms to different portions of the rainbow's gamut. The important truth to remember is that, while the differences between colors are real enough, there are no real divisions between colors. These are arbitrary and imaginary. As is well known, the gamut of radiations of visible light, that we call the rainbow, is not an entity in itself, but is an arbitrary and imaginary portion cut out of a much wider gamut of electromagnetic radiations. The variety of colors in the rainbow arises from the fact that the radiations of visible light come at us in wavelengths of different frequency. As the wavelengths of these radiant forms of energy get smaller, and thus their frequency gets larger, we observe this difference as a shift in color toward the blue end of the visible spectrum. As the wavelengths get longer and the frequency less, we observe a color shift toward the red end of the spectrum. If this shift of wavelength continues, the radiation may pass beyond the range to which our eyes are sensitive. Beyond the red, we can notice these radiations as heat, infrared. Beyond the violet, we might have difficulty noticing the radiations directly, but their consequences would soon appear as a kind of sunburn on our skin. Once again, there is no dividing line between the visible gamut of radiations and the ultraviolet on one side and the infrared on the other side. Some persons can see further into these than others can, and other forms of living creatures can see further into one or the other range than any human could. Bees, for example, are fully sensitive to ultraviolet radiations, while humans are generally so insensitive to these that they consider glass windows, which cut off most ultraviolet, as being fully transparent. The gamut of radiant energy is much wider than the three subgamuts we have mentioned. Beyond the invisible ultraviolet are other radiations of even shorter wavelength, including soft X-rays, hard X-rays, and finally the very high-frequency gamma waves released by nuclear explosions. Going the other way, in the radiation range, we find that there are radiations of increasing wavelength beyond the infrared, which we call heat. These radiations of lower frequency and longer wavelength include those used to carry our radio and television broadcasts. While we sit here reading, quite unaware of their passage, these radiations are going through our bodies. They are different from the visible light that allows us to see to read only in the wavelengths and energy content of the radiations. This great gamut of range of energy radiations, from the shortest gamma waves at one end to the longest broadcast waves at the other end, forms a continuum. The difference between a deadly gamma radiation and an enjoyable television broadcast, like the difference between red and blue, is a very real difference, but it is only a difference of wavelength, and thus a difference of distance, and not a difference of kind. Accordingly, no real lines of demarcation exist in the gamut itself, and the whole range forms a single continuum. The quality of being a continuum that exists in the range of electromagnetic radiations is not a quality that has anything to do with energy or with radiations, but is true simply because these radiations exist in space and differ from one another because of space distinctions, namely their wavelengths. This spectrum is a continuum and therefore irrational, because space is a continuum and therefore irrational. The irrationality of space sounds a little strange to most of us because we are so familiar with space that we rarely stop to think that we do not really understand it. But the irrational quality of space, which arises from the fact that space is infinitely divisible, is one of the early discoveries of ancient intellectual history. By 2000 BC, the Babylonians were familiar with the fact that the square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other two sides. Introduced to the Greeks in a generalized form by Pythagoras before 500 BC, this statement came to be called the Pythagorean theorem. Unfortunately, Pythagoras also taught that reality was rational, and that the truth can be found by the use of reason and logic alone, without any need for observation through the senses, which would merely serve to confuse us. This rationalist method for discovering the nature of reality was accepted by Socrates and Plato, and, in his earlier period, by Aristotle, and led to the death of ancient science by contributing to a denigration of observation, testing of hypothesis, and experiment. It is one of the great ironies of history that thinkers like Pythagoras and Plato helped to kill ancient science by propagating the belief that observation was not necessary, since reality was rational, and therefore its nature could be found by the use of reason and logic alone. Long after a pupil of Pythagoras, Hippasus of Metapontium, had used the Pythagorean theorem to demonstrate that space, and thus reality, is irrational. The demonstration of the irrationality of space arose from the proof that the diagonal of a square is incommensurable with its side. We should say that if the side of a square is 1 unit long, its diagonal, by the Pythagorean theorem, is the square root of 2 units long, and the square root of 2, we say, is an irrational number. But few of us really know what we mean by the word irrational in this sense. There are 3 ways of looking at it, each a slightly different way of looking at a quite irrational situation. We sometimes say that the square root of 2 is an endless decimal which begins with 1.41421, and so on, and continues forever in an infinite series of digits which never ends and never repeats itself. Or we could say that the square root of 2 is a number which cannot be expressed as a fraction, that is, as a ratio between 2 rational numbers. But both of these statements are simply alternative ways of talking about the utterly irrational fact that there is no common unit of distance, no matter how small we make it, which will go into the side of a square a certain number of times, and will also go into the diagonal of the square a round number of times, without anything left over. Rationally, we would think that if we took as a unit of measurement a distance which was infinitely small, like 1/60th of a cat's whisker, or even 1/60th of that, or however small a unit was needed, that we could eventually find a unit so small that it would go evenly into both the side and the diagonal. But the fact is that there is no unit, however small, which will go evenly into both distances, so that there is no common unit between them, and we must say that they are incommensurable. But this is not a situation that is rationally comprehensible to our conscious reasoning powers, and it is quite non-logical. But it is true. This quality of irrationality of space is not something exceptional, either in space or in other aspects of reality. The radius of a circle is similarly incommensurable with its circumference. The irrational relationship between the two distances is signified by the ratio we call pi. This quality of irrationality rests on the fact that space is infinitely divisible, no matter how close together we make two points. The number of points between them remains infinite. The infinite colors of the rainbow, like the incommensurability of a square and its diagonal, or of a circle and its radius, are simply applications of this irrational quality of space. A similar irrational quality is to be found in time. We usually think of time as a succession of intervals. It is really a continuous flow, and any intervals we may choose to put into it, be they seconds, hours, or centuries, are arbitrary and imaginary. And in consequence, any conclusions we derive or any inferences we may draw from such intervals may be mistaken. We have 24 hours in the day, as a purely conventional arrangement going back to our early ancestors in the Neolithic garden cultures, who had a number system based on 12, and passed on to us, as relics of that system, such arrangements as 12 eggs in a dozen, 12 inches in a foot, 12 pennies in a shilling, 24 parts in a carat, 12 ounces in a pound of gold, 12 deities on Mount Olympus, and many other odd facts, of which one of the most pervasive today is that teenage begins with 13. From the Neolithic belief that day or night should each have 12 parts, we derived our 24-hour day. But since these divisions are arbitrary and imaginary, we could with equal justification have a day of 10 hours, or of 23, or 25 hours. Most of us are familiar with the paradoxes of Zeno, especially with the one about a race between Achilles and a tortoise. Zeno argued that if the tortoise got a head start, Achilles could never catch up with him, even if he could run much faster. Zeno felt that if the tortoise was a certain distance ahead when Achilles started, the tortoise would move forward a little farther, while Achilles was covering the handicapped distance, and would thus still be ahead when Achilles finished the handicapped distance. Accordingly, Achilles must keep on running to overcome the new increment, but by the time he had made up that increment, the tortoise would have moved forward a new amount and would still be slightly ahead. According to Zeno, this process would continue forever, the tortoise advancing a decreasingly small amount, while Achilles was making up the tortoise's previous increment. A mathematician might say that the distance between the two would approach zero as a limit, but would reach that limit only after an infinite number of intervals, either of time or of distance, and that Achilles would accordingly not catch up in any finite number of intervals. The explanation of this paradox of Zeno's rests on the fact that the space and time through which the constants are running are both continua. But Zeno, by treating them as if they were a succession of intervals, introduced an untrue condition. And from this, contrary to fact assumption, that time or space exists as a sequence of intervals, he derived a contrary to fact conclusion that Achilles can never catch up. Such paradoxes are good examples of the methodological rule that logic and rationality do not apply to continua. As we shall show later, this is one of the basic rules of historical method, although it must be confessed few historians give it much thought. Space and time are not the only continua. Another familiar example is the system of real numbers. Since this is a continuum, we may state a rule. No two numbers can be placed so close together that there is not an infinite number of numbers between them. For example, between 3 and 4 are an infinite number of numbers. One of these is pi. As we have said, pi is irrational, and accordingly, although it is a very exact number, we cannot write it with the ordinary 10 symbols used in writing numbers. If we say that pi is 3.14, we do not refer to a single number, but are really saying that pi is one of the infinite number of numbers in the gamut from 3.135 to 3.145. In that gamut, we could indicate that pi was in a much narrower gamut, which still contains an infinite number of numbers, by writing its value as 3.141592. This refers to the infinite number of numbers in the gamut of numbers ranging from 3.1415915 to 3.1415925. Since the value of pi is known to over 1,000 decimal places, we can define the gamut of numbers within which pi lies more and more narrowly simply by carrying the numerical expression for pi to more decimal places. But each gamut, no matter how narrow it gets, refers to an infinite number of numbers, because the system of real numbers is a continuum. To those who are not familiar with mathematics, all of this discussion of 2 squared or of pi may seem very strange, unreal and unapplicable to anything with which they are concerned. I hope to show that the remarks I have just made about numbers are applicable not only to statements we all make about many familiar things, but also to history. A moment's thought will show that any statement about any continuum is just the same kind of statement as that which we have just made about pi. Just as any value we may give to pi refers to a gamut containing an infinite number of numbers, and this gamut can be made narrower by carrying our statement of the value of pi to more decimal places, so any statement about any color refers to a gamut that contains an infinite number of colors. Thus, the word orange does not refer to a single color, any more than 3.14 refers to a single number, but rather refers to the gamut of colors between red and yellow. If we narrow this gamut by speaking of yellow-orange, we still are referring to an infinite number of colors, and we could make the gamut narrower by referring to orange-yellow-orange or to yellow-yellow-orange, thus bisecting the previous gamut. This process could be continued indefinitely, just as the value of pi can be carried to more decimal places. The value, however, of carrying either very far is not large. We have been talking about rainbows, numbers, and space-time in order to establish what we mean by a continuum. Now, we can define the term in the sense that we shall use it in discussing history. A continuum is a heterogeneous unity, each point of which differs from all the surrounding points, but differs from them by such subtle gradations in any one respect that no boundaries exist in the unity itself, and it can be divided into parts only by imaginary and arbitrary boundaries. We might add that some continua are perfect, while others are highly imperfect. The distinction being that a perfect continuum has an infinite number of gradations between any two boundaries drawn in it, no matter how closely together they are drawn, while an imperfect continuum has a finite number of gradations between at least some of the boundaries drawn in the continuum. For example, the gamut of variations of light intensity during any 24-hour period is a perfect continuum. But the races of mankind, however defined, are an imperfect continuum, for the variations in any standard we set as a criterion for race can be no more numerous than the number of individual human persons on the earth. That is, no more than a few billion variations, instead of the infinite number we expect to find in a perfect continuum. If, for example, we set color of skin as the criterion of race, and we are to arrange the human beings on the globe in some magical fashion in a long line, with the blackest black man at one end, and next to him the second blackest man, and so on in an ascending order of light reflection from their skin surfaces, until we pass through all the blacks, browns, reds, yellows, and whites, to end up with the whitest white man on the globe, possibly an albino Norwegian. If we were to do this, I feel confident there would be no place on that long line where any two adjacent persons would have any difference in skin color sufficient to be distinguished by any normal physical process. We might then decide that men, based on skin color, form a single race. Or, if we insist on having more than one race, we might simply divide the line at its midpoint and settle for two races, the lights and the darks. But however many races we decided upon, there would be no discernible difference in skin color between any two adjacent persons between whom we draw a boundary line. Nevertheless, in the final analysis, this range of skin color would represent an imperfect continuum, because the variation of skin color between any two boundary lines, or in the range of mankind as a whole, would be numerable and not infinite. We might, on the other hand, arrange mankind in a line on the basis of height. In that case, we would have several billion variations over a total height difference of no more than 7 or 8 feet, giving an average difference between any two adjacent persons of no more than 1/50,000,000th of an inch, a difference which is, once again, too slight to be discernible by any normal procedures, and is indeed considerably less than the normal increase and decrease of any one person's height caused by rest and exercise during a day. Indeed, if we try to arrange the persons of the world in order by height, we would find the daily changes in individual height to be relatively so much greater than the average height differences between individuals that persons would be compelled, from their constantly changing heights, to change their positions in the line by hundreds of thousands and even millions of persons at relatively short intervals. If we were to use such criterion as height as measure of race, we could do so only so long as people were locally segregated into groups of obviously different average heights. As soon as people began to move about or mix socially, the classification would break down, and we could never classify racially on this basis any isolated individual. We deal with continua rationally, either by dividing them into arbitrary intervals, to which we give names, or by giving names to the two ends of the continuum, and using these terms as if the middle ground did not exist at all. This last method is called polarizing a continuum, and is frequently done even when the greatest frequency of occurrence is in the middle range. When the telephone rings, in the sorority house because someone wants a blind date, the sisters at once ask the vital question, is he tall or short? They ask this question even though it is perfectly obvious that the majority of men are neither tall nor short, but are nearer the middle range. Such polarization of continua is so common and so familiar that we come frequently to accept our categories as real instead of being arbitrary and imaginary, as they usually are. An accident report asks, day or night, although accidents are most frequent when it is neither day nor night, but dusk. Many questionnaires polarize continua by asking us to check white, colored, man, woman, pro, con. In English law, this is done in the distinctions between adult, juvenile, or sane, insane. In the social sciences, it is done in such contrasts as monopoly, competition. In economics, democratic, authoritarian, or totalitarian, liberal in politics. We have already done it several times in this book, as in the dichotomy between natural science and social science, or between objective and subjective. The familiar polarization of man into spirit and flesh dominated religious ethics for centuries. The practice of slicing continua into parts, or even into dual poles, and giving names to these artificial categories is necessary if we are to think about the world or to talk about it. But we must always remain alert to the danger of believing that our terms are real or refer to reality, except by rough approximation. Only by making such divisions can we deal in a rational way with the many non-rational aspects of the world. We could, of course, renounce any desire to deal with the world rationally and content ourselves with successful non-rational dealings with it. We can deal with the irrationality of space, time, quantity, number, race, color, and so forth, simply by action. Merely to walk or to run like Achilles is to deal with the irrationality of space and time, and to discover by action who will win in a race. When we merely walk along, talking with our friends, we are, by walking, dealing successfully with space and time. No one could ever walk rationally. Simply stand still and make an effort to walk rationally. What is the first thing to do? And what should be done next? What messages must be given to which muscles, and in what sequence? We do not know, and we could not do such a complicated mental operation quickly enough to walk by any rational thinking process. When we approach history, we are dealing with a conglomeration of irrational continua. Those who deal with history by non-rational processes are the ones who make history, the actors in it. But the historian must deal with history by rational processes. Accordingly, he must be aware of the processes and difficulties to which we have referred when we try to deal with continua rationally. For history deals with changes in society, and all changes occurring in time involve continua. Both society and culture are, even if static, concerned with continua. Indeed, a society is a continuum of continua in 5 dimensions. When we say that a society or a civilization exists in 5 dimensions, we are referring to the fact that it exists in the 3 dimensions of space, the 4th dimension of time, and the 5th dimension of abstraction. All of these are easy to understand, except the last. Let us look for a moment at this 5th dimension of abstraction. It is clear that every culture consists of concrete objects like clothes and weapons, of less tangible objects like emotions and feelings, and of quite abstract things like ideas. These form the dimension of abstraction. For example, in Western civilization we have such items as the following: A. Automobiles. B. Romantic love. C. Nationalism. D. Beethoven's string quartets, and E. the integral calculus. All of these are clearly products of Western civilization and could not have been produced by any other culture. They are different degrees of abstractness, and accordingly, we can say that Western culture exists in a fifth dimension, the dimension of abstraction. This is the same dimension as the gamut of human needs to which we previously referred. However, it is wider than this gamut. It may be similarly divided into 6 levels. In a rough and approximate fashion, these divisions are arbitrary and imaginary, and even the order in which we list these levels is partly a matter of taste. These levels are, from the more abstract to the more concrete: 1. Intellectual. 2. Religious. 3. Social. 4. Economic. 5. Political. And 6. Military. Each of them could, if necessary, be subdivided into innumerable sublevels, as for example, the economic into agriculture, commerce, and industry, or into production and distribution and consumption. Such varied divisions and subdivisions are made possible by the fact that the reality is much more subtle and complex than are the categories of our thinking processes. Assuming such a 6-fold division of culture, it becomes possible to make a rough diagram of the history of any culture by letting the vertical axes represent the dimension of abstraction and the horizontal axes, from left to right, represent the passage of time. Thus, on the vertical axis, we have intellectual, religious, social, economic, political, and military in descending order. And along the horizontal axis, we have 1500, 1600, 1700, 1800, 1900, 2000. In the above diagram, we have represented the changes in culture from 1500 to 2000, the changes that take place in any single level, however we divide it or subdivide it, we shall call development. Thus we may speak, for example, of the intellectual development or of the military development of a culture. The process of change on any single level we shall speak of as historical development, always remembering that the divisions between levels are arbitrary and imaginary, and that we can make as many or as few as we like, because the levels really merge into each other. Since the levels of culture arise from men's efforts to satisfy their human needs, we can say that every level has a purpose. Assuming the 6-fold division we have made, we can speak of 6 basic human needs. 1. The need for group security. 2. The need to organize interpersonal power relationships. 3. The need for material wealth. 4. The need for companionship. 5. The need for psychological certainty. And 6. The need for understanding. To satisfy these needs, there come into existence on each level social organizations seeking to achieve these. These organizations, consisting largely of personal relationships, we shall call instruments, as long as they achieve the purpose of the level with relative effectiveness. But every such social instrument tends to become an institution. This means that it takes on a life and purpose of its own distinct from the purpose of the level. In consequence, the purpose of that level is achieved with decreasing effectiveness. In fact, it can be stated as a rule of history that all social instruments tend to become institutions. The meaning of this rule will appear as we discuss its causes. An instrument is a social organization that is fulfilling effectively the purpose for which it arose. An institution is an instrument that has taken on activities and purposes of its own, separate from and different from the purposes for which it was intended. As a consequence, an institution achieves its original purposes with decreasing effectiveness. Every instrument consists of people organized in relationships to one another. As the instrument becomes an institution, these relationships become ends in themselves, to the detriment of the ends of the whole organization. When people want their society to be defended, they create an organization called an army. This army consists of many persons with different duties. Each person takes as his purpose the fulfilling of his duties. But this soon leaves no one in the organization with the purpose of the organization as his primary purpose. The purpose of the organization, in this case, to defend the society, becomes no more than a secondary aim for everyone in the organization. Defense becomes secondary to discipline, keeping authority in channels, feeding and paying the troops, providing supplies or intelligence, and keeping visiting congressmen or the people as a whole happy about the army, the personal comforts of the soldiers, and so on. Moreover, as a second reason why every instrument becomes an institution, everyone in such an organization is only human and has human weakness and ambitions, or at least has the human proclivity to see things from an egocentric point of view. Thus, in every organization, persons begin to seek their own advancements, or to act for their own advantages, seeking promotions, decorations, increases in pay, better or easier assignments. These begin to absorb more and more of the time and energies of the members of an organization. All of this reduces the time and energy devoted to the real goal of the organization and injures the general effectiveness with which an organization achieves its purposes. Finally, as a third reason why every instrument becomes an institution, the social conditions surrounding any such organization change in the course of time. When this happens, the organization must be changed to adapt itself to the changed conditions, or it will function with decreased effectiveness. But the members of any organization generally resist such change. They have become vested interests. Having spent long periods learning to do things in a certain way or with certain equipment, they find it difficult to persuade themselves that different ways of doing things with different equipment have become necessary. And even if they do succeed in persuading themselves, they have considerable difficulty in training themselves to do things in a different way or to use different equipment. Military history offers numerous examples of the institutionalization of instruments. The Roman army, which had conquered most of the known world by means of the legion, was unable and probably unwilling to transform itself into a force of heavily armed cavalry when this became necessary in the late 4th century of our era. As a result, the Roman army and the civilization it was supposed to defend were wiped from the earth by the charging horsemen of Germanic barbarians, beginning with the dreadful defeat at Adrianople in 378. The inability of fighting men to reorganize their ideas and their forces from infantry to cavalry was one of the vital factors in the replacement of pagan classical civilization by Christian Western civilization. In the centuries from AD 700 to 1200, cavalry, in the form of the medieval knight, became as established in military tactics as the Roman infantry had ever been. In 732, the Saracens, whose relentless advance had begun in Arabia a century before, were defeated by the cavalry of Charles Martel at Tours, and the Christian West was saved from Muslim conquest. By 1099, the Western counterattack had reached its apex in the capture of Jerusalem. In the 3-century interval between these two victories, Germanic and Frankish cavalry under Charlemagne, Otto the Great, and others had saved Western culture from numerous pagan threats. Methods of fighting from horseback had become well established, almost formalized, and had begun to assume those chivalric embellishments that contributed so much to the institutionalization of this method of warfare. Noble youths, as we all know, spent years in jousting and tournaments, to achieve the skill considered necessary for success on the field of battle. The supremacy of the medieval knight was still unquestioned in the early decades of the 14th century. The defeat of French chivalry at the hands of the bourgeois infantry before Courtrai in 1302 was dismissed by the losers as an inexplicable and unrepeatable accident. On the Celtic fringe of Britain, similar defeats at the hands of lower-class longbowmen were more readily recognized for what they were, a new and successful tactic, and bowmen were incorporated into the English armies. By means of this innovation, English mercenary armies were able to inflict a series of disastrous defeats on French feudal forces in the century following the opening of the 100 Years' War in 1338. The inability of the French knights to analyze their defeats is one of the best examples we have of the reactions of an institutionalized force to weapons innovation. Of the numerous blinders on their eyes, the most significant, perhaps, was their inability to conceive that men of low birth could kill men of noble blood from a distance. A similar inability, in the same period, made it impossible for the noble cavalry of Burgundy and of the Habsburgs to analyze their defeats at the hands of Swiss pikemen. The advent of gunpowder and the intensification of firepower made cavalry obsolescent in the early 19th century and obsolete before the end of that century. Yet by 1900 cavalrymen were still dominant in many armies, and enormous resources were devoted to an army that was, by that time, largely worthless. As early as the Crimean War, 1854 to 1856, the poet Tennyson saw that it was a blunder to send cavalry charging against gunfire. The American Civil War should have shown clearly the demise of offensive cavalry, and even the fraudulent nature of its claim that it was, at least, the eyes of the army. Yet the post-war reminiscence of officers were filled with the exploits, largely based on institutionalized self-deception, of military men. Reviewing some of these reminiscences, in its issue of October 31, 1868, the Army and Navy Journal said, "The day of the saber is over. The late Civil War in America, which taught so much both in military and naval science, made it manifest that cavalry had finished its work. Already 50 years before, at Waterloo, the havoc made in the matchless Old Guard, the consummation and ideal of cavalry by the English infantry, had destroyed the prestige of heavy cavalry on the actual battlefield. But since then, the perfection of rifled arms, both in infantry and artillery weapons, had made its downfall absolute. It is a question of shock against shock, and with modern arms of precision, a compact body of infantry can empty every saddle in a charging squadron before it arrives to where sabers can be used." Leaving aside for the moment the fact that firepower, as these words were written, had also condemned any compact body of infantry, we must emphasize the fact that these remarks on the role of cavalry went largely unheeded in military circles. By the end of that century, cavalrymen in all armies except the French and the Germans were organizing, both formally and informally, to maintain the role of cavalry in military forces and to secure promotions for fellow cavalrymen. The talent experts have for seeing what they expect to see, or what they are trained to see, rather than what is there to see, is nowhere better shown than in the tactical discussions preceding World War I. In giving evidence before the Royal Commission on the Boer War in South Africa, that intrepid cavalryman Douglas Haig announced firmly, "Cavalry will have a larger sphere of action in future wars." That was in 1904. 14 years later, as British Commander-in-Chief in France, having succeeded in that post another cavalryman, Sir John French, Haig had to cooperate with the commander-in-chief of the American Expeditionary Force, also a cavalry general, John Pershing. Pershing's obsession with the importance of cavalry made it necessary for him to carry on two wars, one against the Germans and another, almost equally virulent, against Peyton C. March, Chief of Staff in Washington. Much of this struggle, in which Pershing, as a public hero, was generally successful, was concerned with the control of transatlantic shipping space, which Pershing wanted to utilize for horses and fodder, while March sought to reserve it for men and ammunition. In an analysis of this problem in 1935, the military historian Liddell Hart wrote, "French, Germans, Russians, and Austrians had unexampled masses of cavalry ready at the outbreak of war, but in the opening phase they caused more trouble to their own sides than to the enemy. From 1915 on, their effect was trivial, except as a strain on their own country's supplies. Despite the relatively small number of British cavalry, forage was the largest item of supplies sent overseas, exceeding even ammunition, and thus the most dangerous factor in aggravating the submarine menace, while, by authoritative verdict, the transport trouble caused in feeding the immense number of cavalry horses was an important factor in producing the Russian collapse." If you enjoyed this recording, you can find more and support the production of these works at my website, johnlothe.wordpress.com. That's www.johnlothe.wordpress.com. Thanks for having a look and a listen. Your friend, John Lothe.